Okay, so in this problem, we're going to convert the binary tree to a string, then convert the string back to the binary tree. There are two methods. I will first do the BFS method using a queue. So we first define a queue. If the root is a null pointer, we just want to return a special character. And if it's not, then we can make a string. First, let's define the answer, which is going to be returned as the answer. If it is not a null pointer, we want to make a string out of this. String, and we want to add the value, and we also want to have a space, so later on we can use a string stream to break down the string. And we want to push the node into the queue and then traverse the queue. Traverse the tree using the queue. Let's first get the current node from the queue. Then we're gonna see if this is a null pointer. We're going to add the string, the answer string with a pound sign. Otherwise, if it's not null, by the way, I think we update the string only when we pop out the string from the queue. So here, really this should not be here. We should delete this. Otherwise, we should generate or update the answer by converting this to a string, the current node to a string. And we want to add also a space. And we want to also push the current node's left node and right node into the queue. And at the end, we're going to return the ANS string. Okay. So for the Deserialize, we want to first build a string SS, define a string temp which will be used to retrieve the string segments from the string stream. Here we also want to use a queue structure to build the tree little by little. So let's first get the first part of the string stream. If it is an pound sign, that means it's a null pointer. We just return. Else, we're going to make a node called root, and this is based on the value of this temp string, and we're going to push it into the queue. Next, we're going to traverse. We're going to build a tree little by little using this queue structure. Okay, first, let's get the current node. Okay, then we want to retrieve, first, if the current node is a null pointer, we just continue. We don't want to do anything with it. Otherwise, we get the next part of the string, and if it is not a pound sign, meaning it's not a null pointer, then we want to build a node out of this. And we want to push this node into the queue, and also assign this node to the left node of the current node. And same thing we do for the right side node of the current node. And at the end, we want to return the root. Okay, let's go over this one more time. So in the serialize, we declare a queue. We check if the root is a null pointer. If it is, then we just return the pound sign. Define an answer string, push the root into the queue, go through the tree using the queue. First get the current node, and if it is a null pointer, we add a pound sign to it. If it is not, then we add a we convert the current node, by the way, should be a value, to a string, and then add it to the answer. Then we push the left node and right node into the queue. In the end, we return answer string. In the deserialize, we have a string. By the way, should be initialized as data. Then we get the temp. We also define a queue structure. We create a queue structure to go through to help to build the tree by BFS, layer by layer. So we first get the root node. If it is a pound sign, then it's a null pointer, we just return. Otherwise, we make a root node according to the value of the temp after converting it from string to integer. Push the root into the queue and go through the queue. Get the current node. If it is a null pointer, we just continue, we go to the next to the next node in the queue. We get the next segment from the string, check if it is not a null or not a pound sign, then we create a new tree node, push it into the queue, and assign it to the left node of the current node. And same thing for the right side. And at the end, we return the root. Okay, let's run a test case. Okay, one more test case. Okay, and submit. Okay, so it's passed. Accepted. So that is a BFS method. Next, let's try to use the DFS method, which is actually easier. Okay, so if root is equal to null pointer, we just return this pound sign. Otherwise, we use pre-order traversal to string and we have a space between the left and right and the root. We use recursion. Again, a space between the left and right. Okay, that's it. That's pretty simple, right? So for deserialize, use string stream and again we want to use recursion. So string temp, and we want to give this to temp, get the first segment of temp. If temp is pound sign, we return null pointer. Otherwise, we make a tree node. Root it is made out of the temp, and for its left node, we want to use this function itself to get its left node, and same thing for the right node. And eventually we just return root. It's also pretty easy. Okay, let's go over this one more time. If root is null pointer, return a pound sign. Otherwise, we return according to the pre-order traversal. Return the root and convert it to string, then plus the left side string and the right string, and these are separated by the space. And then for deserialize, we make a string stream, get the first portion of the string stream to temp. If it is a pound, return a null. Otherwise, we make a new pointer. Make a new node, and according to this the value of the temp, then assign the left side of it, assign the right node of the root, and return the root. Okay, let's run some test cases. it says, okay, I think I made a mistake. I need to really define a helper function. And to call itself. Let's take a look at this. I think this is correct. Let's first run one more time. Deserialize SS. No viable conversion to string. So this should be helper. Okay. Submit. That's right.